All right, guys. So here's the deal. Yesterday, I went to see a client, and he said to me, "No, his garage door closes, and then it just and then opens again. So what's going on here?" And he sent me some photos, and I saw the photo. It's a Gemini garage door motor, and fantastic. I thought, okay, well, that's easy enough. I know what's going on there. So what is happening when your garage door closes and when it opens is you'll see two of these on the Gemini, and these actually sit on the extrusion or that rail that the little traveler goes along. It's called the traveler, and that's called the extrusion, the whole bar with a chain in it. And that traveler goes, it hooks into the magnets. I have done a video on changing the traveler. This one is on the end stops. So normally on a garage door or gate motor, you have to set its limits, and you have to say that's where you open and that's where you close. And Gemini and the Digidor 2, the old Digidor 2, um, they operate on a magnet and a reed switch basis. So as it happens, and I tested each one, they're very easy to test. All you need is a multimeter, and that you stick it onto diode, that it makes a noise. And so when there's continuity, it's going to make that beep. Um, let's see if I can get the other microphone on this and see if it will record that beep, because you probably won't hear it. I'm not sure if this is going to work. So what I'm going to do is put this over here, and you'll be able to see this is open line. And when you close it, sorry, you probably got a bit of noise. It will give you a reading, a small reading, or zero, and that means that there's continuity. So I tested this one. I took it off. You can replace the whole harness, but you can also just replace the reed switch, which we'll get into. So when I put it on, now this is actually a magnet. It's off the gate motors, and when I put it near here, I've got nothing. So I know this is not working. I can also test the continuity with it on the door. Where it plugs in, you'll see a white and a black going into one, and then the white will go into the other and the black will go into the other. So you want to test continuity between the whites, because that is the closing sensor, and the blacks are the opening sensor. So one tells the door it's open, the other one tells the door it's closed, and it must stop working. If it doesn't know that, it's going to continue running, and then it actually registers a collision. And once it's got that collision, then it's going to open up again, as they all do. So what I've done is cut this off, and we're going to open it up now. And you'll see this folds around also through there and goes back, and it clips on the rail like that. That just clips off, and you can strip it. So just to make things a little bit quicker, they do, by the way, have one on there. Garage motors also, same thing. And that handle actually closes on there, and the magnet inside here activates that switch. That tells the controller that the gate is no longer on manual, and that it needs to see where it is. So if you slide that out, you're going to see a reed switch in there. Right in there, that's this little thing here. So I'm going to slide it out just a bit, because I actually want to put it back together the same way it came apart. That to me makes sense. So what is a reed switch? It's quite simply two reeds of steel in a glass tube. Now let's see if we can get some focus on this. There you can see quite nicely um, that it's two little pieces of steel, or two flat pieces of steel. And let's run some continuity through it and see what it does. So pop one on one side, pop one on the other side. And before we do that, I'm just going to fire up the soldering iron so it can get a little bit warm. These little gas ones that you get at Ardendorf are quite cheap. I think they're 650 or 700, and they really, really do work a treat. They do warm up quite quickly. And here's our Electrics. So now I put it back in continuity, and there's nothing. When I move a magnet or the traveler past, there's continuity. So that's how it knows when the traveler is there. So when your door is open or midway, you can actually lock the traveler back in, and it will find its own points. It doesn't have to go searching for the limits again and doing all these things again. It's just going to do, it's going to move until it finds. I'm trying to do this on camera, so it's not exactly the easiest. Now, it doesn't really matter which way where this goes, but I do like to put it back on the way it came off. Now, what I wanted to do is really just swap just having a close look at the lines on it and markings, and I think it goes on that way. So I'm going to first clip this one to length. It doesn't really matter because it works all the way around, right? As we've seen with the magnet. Wrong one. Those are the pliers. So it's possibly easier if you don't have all the kit. You just get another. We'll start off with that one. You just get another entire harness and replace it. But you know, these are not that expensive. So I'm going to attempt to desolder it. And I should do that with something sharp. I'm going to use this. No, I'm going to actually just use this to try and just remove that when the solder comes off. And let's see. Whoops. That isn't probably not good. And it is got up. There it goes. It's loose. And then I'm going to cut that to length also, which is about around about, because I do want it to fit back in nicely. It's very finicky soldering little things like this. I'm not really fond of it. I do sometimes lack the patience. But what we are going to do is attempt to resolder it back in position where it was. So we'll clean and tin the bit of it a little bit. And we're going to get a bit of solder on here and find our reed switch and line it up again, and off we go. Polarity on these things do not matter. It seems to me that direction also does not really matter. You know, you do obviously want them pulling back, pulling in the same direction. They very, very, very tricky. I'm going to try to do this without swearing, and I can't really promise that. And if you're using the coffee table, I would suggest not burning it for too long and not burning the coffee table. And I think that took. More just a case of, you don't want to cook all the flux out. And let's take off the other one. It's in the bit and get it on. The flux actually cleans the steel, makes the solder stick. So we kind of need that. You also kind of need a plan before you go in. So you want to measure it up, make sure it fits. And you don't want to burn through the wires at this point, because that will result in the door constantly thinking it's closed. So we're going to just nib that on, tin it up a bit. It's called tinning the bit. Pull the tip on a soldering iron. And that did not stick. So if you have low quality solder, or if you have corroded wires, or if you don't have enough heat, or a dirty tip, a lot of these things are problems that you will experience. But it does seem to me a little bit like we've got a really good connection there. I'm going to open it up a bit and really get some solder on there. Because normally when you're soldering something, you're going to see that flow over the steel as the flux cleans it. And you put enough heat into it, and you get yourself a bit more of a shiny joint, like that. Right. So now we are done with this. And we've got something relatively neat. Nicely-ish. I'm not 100% happy, but I'm never 100% happy with solder. It's like it's my thing, unless there's 15 million tons of it. You can see this wire here is not fantastic. So I am not at all happy with that joint. In fact, with either of them. So I'm going to reignite the solder, get more heat in, and ensure, I've gone a bit off camera here, ensure that we have a really good and solid connection. Failing that, I will pause this and I will go and get a better roll, high quality solder. Okay, that clearly isn't going to work. So it is not the end of the world. What we do is we simply cut it back. And we start again. And I'll tell you why we cut it back. That wire was pretty dirty, right? And not so it isn't going to make the greatest of connections. You can see that copper is a lot cleaner than it was. So that is my bad there. What I did was I did not clean up the solder nicely, and as a result, how are we going to do this? We're going to do it that way. As a result, dirty wire did not give me a very good connection. So I'm glad this has happened on camera. That's what everyone who makes a video says. I'm glad it happened on camera so you can learn. Well, you know, not really, because it's very frustrating, isn't it? And you see now this solder sticks to the wire a hell of a lot better. And that is actually a joint. I keep flicking the soldering iron off to the side to get rid of the excess solder. So what we're going to do is cook this last bit off, and we're going to redo that also. Because if you do not have, make sure that's cooled down. If you don't have a really good connection, yeah, with this vibration, it's going to break very, very, very quickly. And we don't want that. We want it to go on and never have to come off again. So normally this copper can corrode from the inside, and that actually, the corrosion actually moves along on the inside of that wire. That's what happens. Okay, that is going to work. I'm inclined to try and wrap it around, which kind of worked. But not very well. I have crap on the end of my soldering iron. You can see it's a bit cleaner. Right. I actually think this solder is not the best quality. Which is fine. Can get binned. Yep. All right, I'm going to pause this. All right. Got some proper solder. I'll clean the tip a bit. And as you can see right there, we have got had they just didn't want to because something was. It's also why I hate doing this. I'd rather just buy a new harness, but we had reed switches, so we have to use them. There we go. We got ourselves a decent connection there. Going to be a little bit warm, but it is also on. So, well done me. Let's put it back in if we can. do have a little bit of extra plastic here. Let's just move that out the way. Plastic insulation. Got to be quite slim, and they've got to be quite in line like that. And the flat face facing inwards. And we put that in there. It will go in all the way to the end. And we pull that out there. And then that wire, I'm going to cut it and refeed it where it was. So when I go and connect it, I know this is quite a long video, but all my videos are quite long. We'll be testing it, and then you will see the end result and how we test it as we install it. So let me get this on. There, the cat has decided to join us, and this has decided not to play ball, but it will. One of them doesn't want to. It's got a little hole. It has to go back through that little hole there. Let's trim one back. See if we can't feed it through that way. And there we go. So we have replaced the reed switch. It's been a bit of a struggle. Some things we've learned: buy decent solder. The other solder's been sitting in a bag for ages, and I think it does start to corrode. And you want to test it first without a magnet. So let's get our multimeter back on. And there is, so now that sits on the rail like that. And our magnet passes through there. So as the traveler comes, and we know that after some effort, we've got us some decent joints. So I'm going to say that is now ready to install, and I think we should continue the installation bit tomorrow. Alright guys, apologies for the loud beeping on that last video. I'm going to have to try and edit it. We are back on the rail. You see how it just clips on, and I'm going to close the door, and you're going to see traveler coming down has a little magnet on it, and as it reaches that magnet, it then stops. So, job done.